Hey, welcome to my koch snowflake. So this is what you're greeted with, and you can change the order by pressing that little order button there, go up and down. At about 12, it starts really slowing down. It takes about 3 seconds from memory, but all the other orders are pretty all good. Zoom in with that, you can press those buttons, or you can use the mouse wheel to zoom in and out. Now, if you zoom too far in, like here, you can drag by holding on the mouse to like drag around like other softwares kind of thing. And if you get lost, just press that little reset thing and you can change the mode, light or dark. Yeah, that's the program. So we've got the UI component here. Basically all it's doing is adding the mouse listeners, interacting with the UI. And you've got two panels, the koch snowflake and the button panel. The button panel is the thing at the bottom with all the buttons. You've got the order one, the zoom, reset, and the different modes. And they've got action listeners that listen to them. But yeah, that's pretty straightforward. So this is the main thing, which is the actual koch snowflake. So here we've got some default values and the construction. Some accessing methods for other methods for the buttons to use. And this is the main thing here, the paint component. This is called every time repaint is called. The size of the triangle defaults to 0.75 if you're on zoom level 1 of the window's lowest dimension. And the center values are calculated, and they may have an offset if you've dragged. Yep. And then we've got the 3 points of the equilateral triangle that we've got to figure out. So we've got some calculations there which calculate the equilateral triangle. And they'll change depending on where the center is and the size. And then we've got 3 calls to our recursive draw a koch triangle method here. And this method, so we've taken heaps of parameters actually, but 2 points, the angle, size, and the order. And so basically those 4 calls there result in a pattern, and this is a pattern here. So those 4 are called in unison. The angles are changed in order for it to create that pattern, and which is calculated with trigonometry, the endpoint for each of those points based on the angle. And so we've got the combination of those 4 there, and so every time there's a line, that will be replaced by a pattern in a higher order. So every line, it's very recursive, this program, so it's very good to program with the recursion. And that finally stops when you actually you meet the base case. And that's pretty much the program though.